So in this particular section, I'm going to talk about single imputation. Again, I'm using this particular textbook, and in that textbook, I'm going to use the section 1.3. Alright, and this is the description of methods by which we can do imputation. See, in here one of the method is mean, and I'm going to use that method at first. So to impute data, and we are doing single imputation, right? So we can do m equal to 1, and this is the number of iterations, mostly useful for convergence purposes, and this is the method that we are going to use in this particular data set. So in here you can see, once I save it as imputation 1 and I have imputation $1 and IMP, it gives me what are the values that it is imputing. You see all of the age values are the same, all of the BMI values are the same, cholesterol values are the same, diastolic blood pressure values are the same, because we are simply imputing the mean of whatever the available variable value information are, right? So see what did I do? I just used the mice function from the mice package, and once I do the save the imputations in imputation 1 object, I can get the complete data set. I can see the complete data set, and this is the first data set, right? Remember, I have imputed just one times, that's why I only have one data set, and I can see this data set where diastolic blood pressure 67.6. These are the observations that were not available in the original data set, and we are simply imputing the mean value in here. Alright, what else? After that we have regression imputation, and for regression imputation we are basically going to use norm.predict, and because we are imputing some continuous variables, this is a method we can use. Basically, say for example, if age was a variable that had missing values, and then we are using BMI, cholesterol and diastolic blood pressure as the predictors to predict our age based on whatever available information we have in our hand, and then we are imputing this age, as well as we are doing the same for the other variables, BMI, cholesterol. So in this case what we are doing is that then BMI becomes the dependent variable and independent variables are all the other variables. Same for the cholesterol. In here what we are doing is cholesterol is the dependent variable, everything else is the independent variable, and that's how we are imputing all of these values, missing values. And then this is the original data. I am fitting age versus BMI, and I am getting a R square, adjusted R square of this, and I'm getting the correlation between this BMI and age 0.05. but when I'm using the complete of this imputation 2 that we just imputed in here, then you can see my row or the correlation between the age and BMI is increased. And you can also try to find the correlations of age and BMI directly instead of this regression method, and you will see that when you do pairwise complete observation correlation, you get a reduced correlation coefficient, but when you do the correlation coefficient of the entire data, you get a more pronounced correlation coefficient. The other method we are going to use is again regression, but this time with this error term that was not present previously when we fitted our regression. See, there is no error term here. So in the stochastic method we do have an error term, and in here what we are doing is that normal dot nob stochastic regression imputation, whereas previously we used norm.predict without the error term. So after this we again impute, and this time see these values are different, these are not same anymore. And then when you fit the regression, you can see the correlation coefficients are giving different signs. That means that before imputing and after imputing the results are different. And the last one I'm going to talk about is the predictive mean matching. And in predictive mean matching, say for example we are dealing with a variable age that has some missing value, right? And we do have other variables that are predictive of age. So age is our y variable, our outcome variable for our imputation model, and we are using BMI, cholesterol, diastolic blood pressure as the predictors of these missing values. Then what we do is that based on the complete case we run a regression of y on x plus the error term, and then we get some beta coefficient associated with this, and we try to generate new beta coefficients based on the beta value that we get as the mean of the normal distribution, and the standard error that we have for these are the variance matrix that we are going to use here. And then using this beta star that we have, we simply generate and sample some beta star, and based on that we predict our predicted age. And then say for example the subject 19 has this predicted age of 45.5, and then what we try to do is we try to find other subjects that have similar predicted age. Mind that we're not talking about actual ages, we're talking about predicted age. And then we try to find out, say for example subject 2, 15 and 24 has the predicted age of 43 something, 45 something and 46 something, and these are predicted age. Maybe the real ages are something close, 43, 45 and 46, but these are the predicted age that are close to the predicted age for the person who has missing age observation. And then what we try to do is that we try to randomly select one person out of these, and say for example subject 2 is the random subject that we select, whose predicted age was also close to the predicted age of subject 19, and then we capture the true age for this person, subject 2. The true age or observed age was 43, and then we use this 43 to impute subject 19's missing age. That is how basically the predictive mean matching method works. And in R, what you can do is you can simply specify method equal to predictive mean matching or PMM to do the imputation using the predictive mean matching. And after predictive mean matching, you can see the correlations change slightly. So in the next lab, I'm going to talk about multiple imputation method and the workflow.